All right, y'all. So 2.4 deals with the algebra of functions. All right, so we're going to look at four operations. So given f of x and g of x. So the first one, f plus g of x. So f plus g of x, the sum of two functions, equals f of x plus g of x. Now, when we're adding two functions, our functions will be in parentheses. So what we do on this, we're going to drop parentheses. And then add like terms. So y'all adding, that's the only thing you can do is add like terms. Even on the variables have to have the same exponents to be like terms, okay? So then we got subtraction, f minus g of x, which will be our f of x minus our g of x. So the difference between subtraction and addition is on subtraction, we gotta distribute the subtraction through the second parentheses. So we're going to still drop parentheses. But we must distribute the subtraction through the second parentheses. Then combine like terms. And that's why I went on and did that 2.4 support the other night or the other morning, so that you would figure out how to distribute through them parentheses, okay? Third will be f times g of x. So y'all, that'll equal our f of x times our g of x. So on this one is multiplication. So remember, on multiplication, you might have a distributive property. You might have to FOIL on those, okay? And then our last operation for number 4 will be f divided by g of x. That'll equal our f function divided by our g function. But y'all, since that's a fraction, you got to set a stipulation on that. So y'all, this g of x cannot equal what? What do y'all think? Well, if y'all think about the other day when we were worried about them fractions on that domain, what could the bottom of those fractions not equal? Oh, perfect. It cannot equal 0. So That's always going to be a stipulation when you got a fraction, okay? Them denominators cannot equal 0. All right, y'all, let me let one in real quick. Prove it. Okay, so let's start working some of these functions. So for my first example, we're given f of x equals x squared plus 2, and g of x is going to equal x plus 3. They want us to find f plus g of x. All right, so they want me to find the sum of two fractions. So we'll come down and put f plus g of x. Now remember, put these functions in parentheses when you first write these out. So our f of x will be x squared plus 2. We're adding that to our g of x function, which is x plus 3. So when things are being added, we can drop the parentheses and bring everything out as it looks. So if I drop the first parentheses, I get my x squared plus 2. Then that brings out this positive x plus 3. At this point, remember, all we can do is add like terms. And y'all, on this one, let's see, the only like terms we have are the 2 and the 3. Now, here's the thing on these problems. You got to write these answers in descending order. You want the highest exponent first, then the next exponent, and then your numbers. So going in descending order, we would put our x squared first. Then we would bring down that x. Then we would add our like terms, and our 2 plus 3 would give us a 5. So remember, the variable with the highest exponent, then the next exponent, then the number. And at that point, we got no more like terms, so we're done. All right, next example, we're given f of x equals x squared minus 4. G of x is going to equal x minus 2. So on this one, they want us to find f times g of x. So a little multiplication on this one. So let's come down. F times g of x. Now on these, I'm going to put my parentheses right next to each other, because remember, that represents multiplication. And I'll have my x squared minus 4 for my f, and my x minus 2 for my g. So anytime these parentheses are right next together, we represent that as multiplication. And y'all, since we have 2 things times 2 things on this one, we're going to do a little foiling. And that's another thing that 2.4 support went over, was that little bit of foiling for us. Now, when I multiply these variables, I treat this x like it's got an exponent of a 1 by it. So anytime a variable does not have an exponent, it's a 1. Because y'all, we're going to multiply the x squared times the x. So that comes down as an x. When you multiply the variables, you add those exponents. So 2 plus 1 will give me an x to the third. Then I take the x squared times -2. That'll give me a -2x squared. Then we got to distribute this -4. So -4 times x gives me a -4x. And y'all, finally, that -4 times that -2 will give us a +8. So when you're foiling, be careful with your signs, okay? Positive times positive was positive. Positive times negative was negative. Negative times positive was negative. And then a negative times negative was a positive. So notice no like terms, because these variables do not have the same exponents. And y'all look at that. We were lucky because this one ended up in descending order. My highest exponent, then the 2, then the 1, then my number. So, questions yet? So, watch this one. I'm going to throw you a little curveball here. We're given f of x equals x squared minus 3. G of x is going to equal x minus 1. They want us to find, let's see, g times g of x. So I'm going to come down here, g times g of x. So I'm multiplying again. So once again, my parentheses will be right next to each other. But y'all, here's the question. What am I putting in these two parentheses? Definitely x minus 1, because this is g times g. So they gave us the f of x for no reason at all. We're not even using the f of x. They want g times g, which will be that x minus 1 times x minus 1. And once again, if you don't have exponents, you can treat the x's like they got an exponent of a 1. Oh, y'all, so the x times x, 1 plus 1 will give me an x to the second. X times -1 is a -1x. Also remember, if I do not put a number in front of these variables, it is also a 1, okay? Now, we got the x -1 times x is another -1x. And then the -1 times the -1 will give me a +1. So when you multiply the same thing times itself, these two middle terms match up, which basically means they double. So these are my like terms in the middle. So going in descending order, I would bring down my x squared. -1 plus a -1 gives me a -2x. And then at the end, I bring down my +1. So here's the thing I want y'all to notice on this. When I was adding I did not change the variables when I added. The only time I could change these variables was when we multiplied. Okay, so when you add, you're not allowed to change ways the variables look. Alrighty, y'all. So I'm going to go to the next one. Move that camera back up. So given f of x equals negative 18x plus 8, g of x is going to equal x squared plus 5. So on this one, they want us to find f of negative 2 plus g of a negative 2. Now, y'all, I'll tell you the truth. Since both these have a negative 2 by this, they could have said find f plus g of a negative 2. Okay, because we're putting the same number into both functions, so they could have wrote it like this if they wanted to. So let's play with this. F of negative 2 plus g of negative 2 will equal my f function plus my g function. But notice, they're now giving me a number for these. So on the f function, they want me to put a negative 2 in place of that x. So we're going to come down and have our negative 18 times negative 2 plus our 8. For the g, they want me to put a negative 2 in for the x. So that'll be negative 2 squared plus 5. Now, I have to stress this, but if you do this on the calculator, you want to put these negative numbers in their own set of parentheses. All right, so we're going to do PEMDAS, order of operations. Start with parentheses. Well, both of these parentheses have work we can do on the inside. So on the inside of each parentheses, we'll follow order of operations. So the first one, you got to multiply before you add. So that negative 18 times negative 2 will give us a 36. Bring down our plus 8. Second parentheses, we got to do the exponent before we add. So negative 2 squared will give us a positive 4 plus our 5. But y'all notice I can still work inside of each parentheses. Now, since I've only got one thing to do in each of these, once I add, I'm going to drop parentheses. So the 36 plus 8, oh, what's that? 44 plus my 4 plus 5 gives me a 9. All right, parentheses are gone. All we got to do is now add these final two numbers. And that 44 plus 9 will give me, oh, what's that going to be? Oh, that what, 53. So they're not too bad. You just got to look at what they want us to find, and are they putting any numbers or anything in place of those X's, okay? All right, y'all. So let f of x equal a negative 11x plus 6. G of X is going to equal X squared plus 14. So on this one, they want me to find F of -5 divided by G of -5. Now this one, I'm going to show you how to do this one on the calculator. So let us work it, and then I'll show you how to do this one on the calculator. Now remember, they could have said F divided by G of -5, just like they could have wrote this one like that, okay? So this one could have been F divided by G of a -5. I always use this shorthand. MathLab, for some reason, goes old school. Only way I would write something like this is if I had different numbers going in. Okay. All righty. F of -5 divided by G of -5. So on top, remember, they want me to put a -5 in for that X. So on top, I got -11 times -5 plus 6. On the bottom, I'm putting a -5 in for the G. So remember, put that -5 in parentheses, square that, and then add 14. So in a second, I'm going to show you how to put this right here exactly like it looks into that calculator. And y'all, I'll tell you what, the reason I didn't put parentheses around this is because when it's in the fraction form, it's understood that there's parentheses around the top and bottom, since we got this as our numerator and this as our denominator. So working that order of operations on top, we got to multiply before we add. So -11 times -5 gives me 55 plus my 6. On bottom, we got to do the exponent before we add. So -5 times -5 gives me what, a 25 plus 14. And if you notice, all I can do now is add on top, add on bottom. 55 plus 6 gives me 61 over 25 plus 14 gives me 39. So at that point, technically, you would try to simplify this. But y'all, I think 61 is a prime number. So that means this thing's not going to simplify. But I'll show you. Let's play with the calculator a second. So let me share that calculator. So the first thing, let me show you how to see if 61 over 39 would simplify. I would do my 61 divided by 39. When you hit enter, that gives you a decimal. But if you would hit this math button, see how it says number 1 fraction? That means if you hit enter and enter again, it'll turn it back into a reduced fraction. But notice I still got 61 over 39, so it does not simplify. Now, the other way to do fractions, this green alpha button, if you hit the green button and then the y equals button, option number 1, ND, that means fraction form, numerator, denominator. So if you hit enter on that, look what it does. It puts a fraction on my screen. So let me write that problem in. -11 on top, parentheses, -5, close parentheses, and then we had a plus 6. Then I'm going to arrow down to the bottom, we had -5 squared. So remember, I'm going to put my -5 in parentheses. I'm going to hit the x squared button to square it. And then I had, what, a plus 14. So let me arrow out of that. So y'all notice that looks exactly like our problem. Now, the nice thing about this, if you use the alpha y equals to get the fraction, it'll write the answer as a reduced fraction. So when I hit enter, there we go. We got our 61/39. Okay. So I really like the calculator when it comes to fractions. So remember, right here, to make it a fraction, we hit the alpha and then the y equals, and then we choose the ND option. Okay. Oh, y'all, let me see what I got here. We're going to let f of x this time equal -2x plus 3. G of x is going to equal x squared minus 4. We're going to find g minus f of x. So let's start that out. G minus f of x will equal my first parentheses minus my second parentheses. So now we got a little subtraction going on. The question is, what are we putting in these parentheses? So what would y'all put in the first parentheses? Oh, perfect. So notice they do got the G first. So good job, Hannah. We got to put that x squared minus 4 first. Then we'll put our f over here, which was a -2x plus 3. So I'll write the first two things down. I'm going to bring down that x squared minus 4. The question of the day, what two things are coming next? And this was where that sort of support homework would have helped you on this one. So y'all, what's this going to give me? When I distribute that negative into them parentheses, you got a negative times a -2x. So definitely, Charlotte, we're going to make that a positive 2x. And then that negative times that positive 3, good job, is going to give us a -3. So remember, distribute subtraction, we almost treat it like a -1, and we're just multiplying by both of those. All right, y'all look at that. We do have like terms here with these numbers. So let's put this in descending order. We'll put our x squared first. Oh, then I had what, a positive 2x. And then -4 added to a -3 give us what, a -3. 7. So that's the main thing. That's the only difference between adding and subtracting, is that subtraction, we do got to distribute through. And notice when you got nothing in front, they come out the way they look. But when you have that negative in front, everything inside changes its signs, okay? All right, so I'm going to throw a tricky one at us this time. So the last of these, and they throw a little curveball on it, and then we'll play with some of that domain stuff, okay? So for this one, f of x is going to equal x squared minus 12. G of x is going to equal 11 minus x. So they want us to find f times g of a little n. All right, y'all, so here we go. F times g of a little n. So notice we're multiplying, so I'm going to put my parentheses right next to each other. But what I want to know is, what's going in this first parentheses? So let's see if y'all get that one, okay? Oh, you're so close, Hannah. But there's one thing you need to change on that. Because what is sitting here in these parentheses? There you go. I need the n squared minus 12. Good job. So remember, if they put a letter here other than x or a number, we got to put that in for those x's. So the second one's going to be what? 11 minus the n. Now, y'all, let me tell you a little trick about Math Lab. When you do the Math Lab, if they give you a little n, you got to put a little n for your answer in Math Lab. Okay, if you put a capital N in Math Lab for the answer, it will mark it wrong. It's got to be the same if it's capital or lowercase as they're using, okay? All right, so we get the FOIL again. So our n squared times 11 gives us 11n squared. Now remember, this is n has a 1 for it by the exponent. Now keep up with the signs. Positive n squared times a negative n is a negative n to the third. Then we're going to distribute this negative 12 times 11 is a negative 132. And then watch this last one, a negative 12 times the negative n is going to give us a positive 12n. So my question would be this. Can you go any further on that problem? Oh, good job. You got to put them in order. But like you said, there's no like terms. So all we can do is put them in descending order. Now, y'all watch this. This n3 is the highest exponent, and it's negative. So you got to bring that negative with it. So you're going to have your negative n to the third. That's positive, so that's going to be a plus 11n squared. Let's see, next to be our positive 12n. And y'all finally, the minus 132. So that's what they want, descending order. And y'all, good job, because you couldn't add no like terms, but if you put it in like we had it here, Math Lab would probably say, although you got the answer right, you're not in the correct form, which would tell you, hey, I got to put that thing in my descending order. All right, y'all. So we're going to, these last three problems, we're going to play with some of those domain questions. So for the functions, f and g, we're going to determine the domain of the sum difference and product. Now they're giving us on this one, f of x is going to equal x squared. My g of x is going to equal 4x minus 7. So we got to figure out the domain of the sum. Then we'll come and figure out the domain of the difference. Then we'll come and figure out the domain of the product. So I'm going to start with the sum. The sum would be f plus g of x. So that'll equal my f, which is x squared, plus my g, which is 4x minus 7. So here we go. Domain. Remember, we use them little curvy parentheses. So the question, what is the domain when I add these two functions together? Remember, our domain will be x such that. So y'all, do y'all want to try that? What would be the domain if I try to add these two functions together? So do we have any restrictions on this problem? And this will sort of go back to what y'all did on 2.3 Tuesday. So let me ask y'all this. Tuesday morning when we was doing the domain of the functions, there's no restriction short of that's perfect because there's no fractions. Y'all remember the only thing we're worried in this section was about the fractions. Well, there's no fractions here when you add these, so no restrictions. So x such that x is a real number. Y'all, that means any real number that you pick, you can put in here and square it. You can put it in here and multiply by 4, and you can work that problem. So good job on that. Let's see what you do with this. F minus g of x will equal my f equation minus my g equation. So we know it'll be x such that. All right, y'all. So what am I going to put here? Yeah, y'all, it's got to be x is a real number because once again, there's no fractions. So I'm not going to get anything that's going to make this undefined. And then finally, we had the product f times g of x will equal my f equation x squared times my g 4x minus 7. All right, so y'all, x such that, what's going here? So I see x is a real number again. Good job. X is a real number. And y'all, I'll tell you the truth. These three operations will always have the same domain because there's no way to turn adding into a fraction. So if I'm not given a fraction as one of these functions, it's always going to be a real number, whether I'm adding, subtracting. I can't turn that into a fraction ever. In multiplying, I can't turn stuff into fractions. So these three operations you're going to notice will always have the same domain. So y'all, let's try another one of those. Let's see what I got on this one. So for the functions f and g, determine the domain, and it's going to be pretty much the same thing. Determine the domain of the sum, difference, and product. So f of x is going to equal 1 divided by x minus 3. G of x is going to equal 7x to the third. So let's start out with our sum. F plus g of x will equal my f 1 over x minus 3 plus my g 7x to the third. So the domain will be x such that. So do we have anything we're worried about on this problem? Yeah, f of x has a fraction. So remember what we did the other day. If we had a fraction, we took that denominator, and I'm going to set x minus 3 equal to 0 just to find what number makes that happen. So y'all, I'm going to solve this. I'm going to add 3. So since I get x equals 3, that means if I put a 3 in here, that's going to give me a 0. And Hannah, you done got it, right? X is a real number, but cannot equal 3. Perfect. X is a real number. And x cannot equal 3. Good job, because y'all 3 is the only number I can put in for that x to make this thing undefined. And we can't add an undefined to anything else. So y'all, f minus g of x will be 1 over x minus 3 minus my 7x to the third. So our domain will be x such that, all right, y'all, what's going here? So Hannah, I guess instead of writing all that out, just write ditto, huh? So there you go. X is a real number, cannot equal 0. There you go. All right, so then we had f times g of x. So 1 over x minus 3 times 7x to the third. And I guess this one will be the same thing, right? Because we've pretty much said up here, all these were going to match. Well, guess what? All these are going to match because you only got the one fraction you're worried about. So here we go for the third time. X such that x is a real number. And x cannot equal that 3. And y'all really think that's why we're separating out the operations on here and doing these 3 operations together so that you'll see they always have the same domain. Now, if I was doing division, that would be a different story. Division is not going to match up with these, okay? So let's try this last problem we got. Yeah, so math lab will have like A, B, C, D, I think. And I think you just pick one of those answers. But make sure you're picking the one with the not equals, because they'll throw like greater than or equal at you, or just the regular equals. And we want the one that has the not equals, okay? So the last one, we're going to change it up. So for F and G, determine the domain of F divided by G. So y'all, my F of X is going to equal 4x minus 5. My G of X is going to equal 5x minus 35. All right, so let's set this up. F divided by G of X will equal my F equation on top, which is 4x minus 5 over my G, which was 5x minus 35. And so we'll put our domain right here. So we know it'll be x such that. So any guesses on what this domain will be? And y'all, let me give y'all just a little bit to play with that. Oh, that is perfect. Because it did have a denominator with a variable in it. So we have to set the 5x minus 35 equal to 0. So y'all, I'm just going to solve this by adding 35. So I get my 5x equals my 35. And then I would divide that by the 5. So that cancels, giving me a 1x. 35 divided by 5 gives me a 7. Perfect. So x is real. And x cannot equal 7. Now notice, we did not have to worry about the top of this fraction, because the top of that fraction can be a 0. It can be any number. The only restriction we had was on that denominator. Okay. Now, y'all, let me show you this on the calculator. Because remember, the only number we kicked out is a 7. So I wanted to show y'all how this looks on the calculator. So I'm going to pull my calculator up. And I'm going to go to my graphing. So I'm going to go to y equals. Now to make a fraction, I'm going to hit alpha y equals and enter. So do y'all notice on top I had a 4x minus 5. So 4x minus 5. Then we'll go down to the bottom. And I had a 5x minus 35. Now, I'll show you what the graph looks like. Now, pay attention to where the x value was 7 on this graph. Y'all see how one side, on the left side of the 7, that graph shoots down? And then on the other side of the 7, the graph is sort of shooting up. That's because that graph cannot cross over that x value of 7 because it was undefined there. Now, later in life, we're going to learn that when a graph does that, when it's undefined, we're going to call that later in life a vertical asymptote. That means the graph cannot cross that x value of 7. Now, watch this table. I'm going to hit second graph and pull our table up. Whoops. Second graph, pull my table up. So notice, as I go further and further in the negative direction up here, you're getting you're getting fraction answers, but all these fractions are real numbers. So let me head the other way to the positive numbers, because the only number we were worried about was 7 down here. So y'all look, I'm getting fractions, but remember, fractions are real numbers. So I'm getting more fractions. But look at 7. At 7, it's giving me an error because we can't divide by 0. But now as I go on these positive numbers, I can click forever and I'll get fraction answers. Okay. Notice I'll get fractions all the way through this. The only place I wouldn't get an answer, like we said, was way up here at our 7. That's where we get the error. Okay, so like I said, no matter which way you go on that, you will get a real number other than that 7. And that is why this graph cannot cross over this at 7. So this graph on this left side keeps going down towards negative infinity, but it never crosses over. And on this other side, it's going up towards positive infinity, but it never can cross over and connect to the other side. So yeah, we'll learn about those vertical asymptotes in the future. I think that's like on our third test material, okay? All right, y'all. So that is 8.4. So now, any questions over anything? All right, so I'm looking at my chat here. Let's see. So not seeing nothing there. So let me stop my share and I'm gonna shut my video off so it'll start loading.